To say that an element is in A intersection B union C means that it is in blank and in blank. Now, we have to look at the operation that was done last. And in that case, according to PEMDAS, this intersection is the last operation because you're supposed to do the parentheses first. And so the focus in number 1, part A, is on this intersection. And we're taking the intersection between two sets. Set A, which goes here, and set B union C, which goes here. Moreover, if you think about the logical AND operation, that is embedded within the concept of the intersection. When you define intersection, you need that logical operation AND, so that you can say that X is in A and X is in B union C. Part B says, to say that an element is in A intersection B union C, in this case the union is the last operation done here, means that it is in, notice here there's an OR this time. OR is the logical operation used to define the union operation, which means that number 1 here is A intersection B, and number 2 here is just C. Part C, to say that an element is in A minus B intersection C, here the last operation is set minus. And also notice that this says and not. In the definition of set minus, we say that X is an element of A and X is not an element of, in this case, B intersection C. And so number 1 would be A and number 2 would be B intersection C. Part D says to prove that A union B intersection C is a subset of A union B intersection C, we suppose that X is an element in. Now, if we think about subset conceptually, this just means that everything in this set is also in this set. Or put another way, if X is an element of this set, which is the supposition here, so number 1 is A union B, then we must show that X is an element of, and then it's the other set, A union B intersection C. So we suppose that X is in this first set, and then we try to prove that X is therefore in the second set, which is what makes a set a subset of another set. Part E, if A, B, and C are any sets such that B is a subset of C, to prove that A intersection B is a subset of A intersection C, we suppose that X is an element of, well, if we're trying to prove that something is a subset of something else, we need to start with an element from the first set. So X is an element of A intersection B, and then we must show that X is also an element of A intersection C. Now you might be wondering, what's the point of saying that B is a subset of C here if really the focus is on this claim that's being made? And the reason is that when you show that X is an element of A intersection C, you will need to utilize that B is a subset of C. And we might get to this in future videos. But the point of this problem is to focus on what needs to be shown. Ultimately, what needs to be shown is that this subset is true. And to prove any set is a subset of another set, you start with an element in the first set, and you prove that that element must therefore be in the second set. Thanks, everyone, and I'll see you in the next video.